Hi and welcome to another video. I'm not sure if I'm going to call this a tutorial video or not, but it's an explanation of an effect that you sometimes see in photographs. The effect I'm talking about is lens flare and the little stars you get from point sources of light. I was looking at an online article by David Hobby about how he photographed a person with laser light in the background, and it created a little star, and I started thinking about how those little stars you get from out of focus point sources of light, how those are actually rendered and how those happen. So I did a little bit of digging around, and I sort of thought that maybe it would be better if I just created my own little video about it and made an explanation. So I'm going to show you some images in a minute that I took with my camera, and I used this flash as my light source. What I did was I cut a hole in a piece of cardboard so that it'd be a circular light source. That helps, I think, to render the stars more accurately. You could probably do it without, but you'd get a sort of a blobby looking effect, I think. It'd be interesting to see what would happen there. And I used my radio trigger to trigger the flash. So I set myself up about 15, 20 feet away and then focused at the closest possible focus distance. So my flash was very, very out of focus in the distance. And so I started snapping away. I started at f8, which is a wideish, sort of middle wide aperture setting compared to the others, and so it let more light in and things were quite bright. But the conventional wisdom is that the more you close down that aperture, although you get increasing depth of field, you will get more of a star effect. So we can see that with this series of photos. The other thing worth mentioning before I go on is that this was an 8-bladed aperture lens. It's a 50mm fixed lens with an 8-bladed aperture. So the more I close it down, the more you'll see 8 star points coming out, and that's why it's important that we know it's an 8-bladed aperture. So we go to f11, and then f18, and finally f22, and you get this nice star effect with the small apertures. You can also slightly see the octagon shape in the form of another piece of flare, another remnant of that light, and it's greenish colored because of the coating on the lenses. So that's what a star looks like from an 8-bladed aperture. 8 points of light, and that's how that looks. So that's pretty nice. What does 6 blades look like? Well, you'd think it's a hexagon, so I'd get 6 points of light. This is a cheap lens that I've had laying around, another 50mm lens that's fixed, has a different kind of coating on it, so you see a hexagon in blue instead of an octagon in green this time. But the star itself is rendered reasonably well here at f16 with this sort of hexagonal shape and the 6 points of light. So that's 6 blades. I couldn't go any tighter than that, that's just the way that lens was. So then I thought, well, let's find another lens, and here's a 7-bladed aperture, and this is where things get really interesting. And actually David Hobby's photo was with a 7-bladed aperture. Might find a link to that to put in my blog posting. But for the purposes of this video, I found a 7-bladed aperture, and you get this almost not a star anymore kind of an image. And so I'm going to attempt to explain that, and hopefully that it'll be clear to you why this is happening with 7 blades instead of getting 7 nice neat points of light. So I've created this little diagram to help explain it. This is on the left an 8-bladed aperture, which results in an octagon shaped hole, and at every corner of the aperture you get this sort of point of light perpendicular to the aperture. Now it turns out that this little shaft of light goes all the way through and out the other side. It's just that with each point being opposite to another point, you can't really see the overlapping lights. The fact that they're overlapping, though, does help to make them appear brighter. Then what happens when you go to an odd number of blades, in this case a 7-bladed aperture, that point on one side of the shape is now opposite nothing else, just a flat side. So that shaft of light is no longer doubled up, but is half as intense, and now you have 14 little beams of light for a 7-bladed aperture. So you get 14 really dull ones instead of 8 really bright ones, and that's what the comparison is here. Even at f29 it's really not very distinct, but there are 14 little blades of light in there all mixed together, and you can't see it very well. Whereas with the 8-bladed aperture at f22 it's nice and distinct and strong. So that's an explanation of starlight for points of light that are very out of focus. Small apertures, large f-stops create more of an effect. You could probably fiddle around with this and use different shapes of light source and different shapes of aperture. You could even cut holes in pieces of paper and card and stick them over the front of the lens to create different apertures, and fiddle around with that to your heart's content. But that's a little bit about lens flare, and hopefully that made sense.